I don't know. I got this from section 6.3, no, 6.2, 21 and 22. So whatever page that's on. So here we have information given. This is already given. Let me use purple for women. Women's heights are normally distributed with a mean of blah and a standard deviation of blah. So let me do women in purple or pink or whatever the heck this is. And since they're normally distributed, I can draw a symmetric bell-shaped curve. The mean, which is mu, is 63.7 inches, and the standard deviation is 2.9 inches. So the center of this curve is 63.7 inches. That means the values along the horizontal scale here represents women's heights. Okay, that's my first situation that is given. Let's do men in, I don't know, green, because blue is a little dark to see. Men's heights are normally distributed with a mean of blah and a standard deviation of blah. So men are normally distributed, so they have this symmetric bell-shaped curve. I'm going to label ND with a mean of 63.7 inches and a standard deviation of 2.9 inches, right? I need to know mu is mean and sigma is standard deviation. The center of this curve is 63. I'm reading women and writing it for men. Hold up. Sorry about that. Men's heights are normally distributed with a mean of 68.6, which makes sense, inches, because I didn't think they should be the same, and a standard deviation of 2.8 inches. So the center of this curve is 68.6 inches, and the values along this horizontal scale represent men's heights. Okay, so these are the visuals that deal with just the information given here. That's not answering any question. I didn't read any question yet. Just the visuals. Okay. So now let's answer a question. So I'll go back to the visual stuff. Let's do 21. Navy pilots. Oops. Sorry. Let me just organize. Make it beautiful. Okay. The U.S. Navy requires that fighter pilots have heights between 62 inches and 78 inches. A. Find the percentage of women meeting the height requirement. Are many women not qualified because they are too short or too tall? So I know that I'm talking about women, right? So let me go back. I'm going to color coordinate, right? So I'm talking about women. So I'll go back to pink or purple, whatever that is. Here. Okay? So I can redraw that if I want to, right? Symmetric bell-shaped. This is normally distributed. The center was, who the heck remembers, 63.7, right, inches. This is part A. And the standard deviation was 2.9, I want to say. That was a good memory on my part. Go ahead. Boom. Find the percentage. I'm looking for percent. Well, first of all, where the heck is 62 relative to 63? It's less than it. So 62 is over here. So 62 inches, okay, is a little less than average for women. That is the lowest part or lowest requirement to be a U.S. Navy fighter pilot. 78 inches, and it doesn't have to be a perfect thing, but 78 inches over here is the highest. So find the percentage. What is percent on this? Percent is, somebody say it.
72.1.
Well, okay, somebody already did it. Area. You got me in your head. Percent is area. I'm looking for percentage. I want area, right? Looking for percent. I want area. If I want probability, I want area. I want area. Want area between these two numbers. So the percent of women who meet the higher requirement is equal to. Now, how do I find that? So I want area. If I want area, I use normal CDF. The lower bound on this area, the smaller value, 62 inches. The higher value, 78 inches. The mean, 63.7 inches. The standard deviation, 2.9 inches. Okay, let me enter that into my calculator. So, second bars, I want to go down to normal CDF. My lower bound was 62 inches, right? My upper bound was 78. Don't forget to input your mean, which is 63.7. And then my standard deviation, which was 2.9. Okay? Those of you that don't have this calculator, you have to just input it in the proper order. This is what it would look like. And your commas are found here. Enter. Is 0.7211. Okay, I'll go 4 digits to the right of the decimal. 0.7211. So this is approximately 0.7211 or 72.11%. So 72.11% of women meet the height requirement for the U.S. Navy fighter pilots. Are many women not qualified because they are too short or too tall? I mean, that's a whole nother, actually, we'll talk about that in a second, but let's just answer the general idea. Are many women qualified? Is there enough? Are there enough women that qualify? 72.11% of women qualify, so that's not so bad. At least I don't think so bad. 72.1, that's majority. Okay, so let me look at B. If the Navy changes the height requirements so that all women are eligible, except the shortest, 3%, and the tallest, 3%, what are the new height requirements for women? So I'm still on a woman's bell-shaped curve, which is obviously, this is a horrible picture of it. I could be better. I could if I want to be particular and do all that extra stuff, but okay. Where would the shortest be? Shortest, that's less, that's over here. The shortest people, smaller people have smaller inches, right? They don't have as many inches as in height. So that's over here. 3% is a small percentage, so it's a small area. So the shortest 3% are over here, 0.03. This is an area in left tail representing the shortest 3%. So there's a data value, right? I'll call it X1, which is a woman's height requirement that separates the shortest 3%. The tallest 3%, obviously going to be up here in the higher inches, 0.03. This is the tallest 3%. And let's call this X2. This is a value which represents our data value, which is representing the height, the new height requirement that separates the tallest 3% of women. Okay, still I'm focused on women. So I'm going to go back to my purple. Okay, so this time I am given area. I know area, and I want a data value. So now I use
inverse norm.
Inverse norm. And I'm going to do it twice. I'll do it for this one, I'll do it for this one. And then you might notice a similarity between the two. Inverse norm here. What do I input next to inverse norm? Always the area to the left of the value that I want. And in this case, the area to the left is given. So no problem, 0.03. Don't forget your mean is 63.7. Your standard deviation is 2.9. And let me set this up and then I'll go to my calculator. Again, inverse norm. What changes for this one though? Area to the left is not known. Area to the right is known. So I have to do 1 minus 0.03 and then the mean and the standard deviation, correct? That's a comma. Okay, so let's look at my calculator. So let's do the first one. Second vars, inverse norm. Area to the left was 0.3 or 0.03, 3%. 63.7 was the mean, and 2.9 was the standard deviation. Always area to the left because not everybody has this choice. And if you don't have this choice, it's automatically area to the left. So I'm just going to keep it that way, right? And this is what it would look like in the proper order without that. Enter 58 point, I don't know what it says. Does it say round to anything? No. So we'll round to the nearest tenth because that's how it was given. So 58.2. So 58.2 inches.
Professor.
Yeah.
I thought you said 1 minus 0.03.
Well, I didn't do this one. Now I'm going to do this one. I did the left height. Now I have to do the right height. So I have to do it twice because there were two heights that I needed. I needed one for the shortest 3% and the tallest. So now let's do the tallest 3%. Inverse norm. I just set both up, and now I'm going to do them both here. So now this is 1 minus 0.03, with the mean the same and the standard deviation the same, blah, blah, enter. So this height was 69.2 rounded. So 69.2, approximately 69.2 inches. So what are the new height requirements for women? Between 58.2 inches and 69.2 inches. Those are the new height requirements for women, based on, the shortest 3% and the tallest 3%.